What I want to get into in this lesson is this thing we call partially applied functions in Scala. And this isn't a feature that I've used a lot personally, but I do use it every once in a while, so I want to make sure I show that. And as a note in the cookbook, the benefit or purpose of partially applied functions is described right here. So you want to eliminate repetitively passing variables into a Scala function. So what you do is you pass common variables into the function first. That creates a new function that's preloaded with those values, and then you use that resulting new function. And you only pass in, at this point, the unique variables that new function needs. Now, if you've never heard of this, that won't make any sense. So what I'd like to do is just come over here and explain this. So what I've done is I created this function right here. I'll scoot that down just for that. So this is a sum function, and it just sums three integers, a, b, and c. And a thing almost everyone has seen before goes a little bit like this. So you can print line the sum of 1, 2, and 3, like that. And then when I save that, do I have this running yet? I do not. Scala CLI, and that's 1, and we'll watch that. And there you see the sum of 6, and that comes from this. Now, a funny thing is, if you've never seen this before, this is what you would call a fully applied function. Before working with Scala, I'd worked with a lot of different programming languages, including Java and Kotlin, and I can't even remember how many others, Dart, and so on. And I'd never even considered the possibility or that this could be a fully applied function. But it turns out it's fully applied because we have fully applied all three parameters to it. Now, what happens is you don't have to fully apply all those. So what I'll do is I'll create a new variable, and I'll say this one's called add two ints to the number 1, and I'll equal that to the sum method or the sum function. I'll give it the number 1, but this is the unique part. I don't have to give it these other two parameters right here. I can just leave those off with the syntax shown, and what that does is it creates this guy as a new function. And actually, as I hover over that, you can see that this variable, add two ints to one int, is a function. And the way you'd read this is that this is a function, and it's expecting to receive two int values here and here, and then it's going to transform those or return an int type right here. So it's waiting for these two int values is the way that works right there. I've given it the number 1, and now this guy is, you can think of it as like being hungry or just waiting for two more integers. And the way I can demonstrate that now is we'll call add two ints to 1 like this. And now a good question for you is, what do you think should go inside this area right here? And if you happen to say, well, it's waiting for two ints, so I ought to give it two ints, well, let's go ahead and give it two integers and see how that works. And I'll press save. And there we go. So now you see the first 6 coming from here and the second 6 coming from right here. And if you want to see something different, I'll change that to 30. So this is actually just the basic technique of creating a partially applied function. It turns out that this guy right here is now a Scala function. And if I hover over that, you see its type again. And as I mentioned, the way you read this is it's now a function, and it's waiting to receive two integers, and it will transform the two integers you give it into a third one, or it will transform these two into a result. So if you look back at the original code, it's waiting for these two parameters, and then it will return an integer result. Still using this algorithm, but what I've done in this case was I put a 1 in there, so you can think of this function right here as being 1 plus b plus c. That's actually what's inside of this one right here. And now we can do this one more time. The first time I did this, I left off two variables, and this time I'll just leave off the very last one here. So it's still partially applied. I've only applied these first two parameters, and I have not applied the third one. And I need to change that name. We'll call this one add one int to 3, and I'm calling it that because I've already passed in 3 right there. Copy that, paste that there. And now this will just take one integer, and that's because it's still waiting for that one right there that I left off. And we could call that one 41 or something like that and save that. And there we go. You see the result down there is 44. So, if partially applied function sounded like something scary, I hope that's not too scary as you look at it over here. This really is the basic technique. It's all you have to do. And now all you have to do is find some real world purposes for this. And that's what I'll show next. Now I have things set up so we can do a little bit more of a real world example. So let me change the formatting on this just slightly so it's a little bit easier to see what I'm doing there. So now wrap is a function and it takes three input parameters, the prefix, the HTML, and then the suffix. And the way I intended this to work is you could call wrap and you would give it some HTML right there, some prefix for the HTML, then the actual HTML that you want there, and then the suffix. And so this might be giving it something like a div tag here, and then a closing div tag here, and something inside of here, and this could just be anything, so hi mom, something like that. And let me save that. And we see that result right there. And this is pretty cool, but if I started doing more things like this, and I'm like, oh, I want another div that would be hi dad, and then another one that would be hi Rover, something like that. You'll notice that I'm repeating the code. I keep having these opening and closing div tags. So the solution for this particular problem is to create a more specific version of this function. So you notice here I call this one a general function. And the way you create a more specific function is I'll create a variable. I'm going to say wrap with div tags equals. And you've seen this before. So actually what I'll do is just cheat a little bit. I'm going to copy here and paste that here. And what we do is we just partially apply this function. So what I'm going to say is, I want this div tag here as the first parameter. I want this div tag as the last parameter, and I'm going to skip this one here. So this function right here will only be partially applied. I'm only giving it two of the arguments that it expects out of the three. So it's only partially applied at this point. So now let me get rid of those things. And now, if I haven't made any mistakes, I do a print line. And I want to do wrap with div tags. And now, because that's partially applied, I put this in here, and now I could say hi rover. So I'm giving it the one final argument that it expects, and that argument is the second parameter here when I call that guy. So if I haven't made any mistakes, I'll save that. And there we go. Cool. One thing I was thinking was I know in Scala 2, I don't remember the details here, but in Scala 2, you actually had to specify the type at certain points. So what I'm saying in this code right here is that I'm not going to apply this parameter, but I do know that it's supposed to be a string. And let's see what happens if I save that. Okay, cool. That still works. So I just wanted to show that it doesn't look like it's necessary in Scala 3. It looks like you can just skip the parameters you don't want to apply. And as a programmer, that's nice because it's a bit more convenient. And I'll just do one more. So again, I'll go back to hi dad here. So again, a good reason for partially applied functions is we start with something like this. And then you saw that previous code I deleted was starting to get repetitive. I kept typing div something close div something close div. And then I was like, okay, I keep repeating myself. And gosh, wouldn't it be great if there was some way to not have to type this and type this every time? And as it turns out, that's what we do with partially applied functions, is we partially apply the wrap function. We give it that first parameter that it wants. We give it the second parameter. So I don't have to keep typing div anymore. Now this function right here is just sitting there waiting for you to give it one more parameter, and then it will return this part right here. And that's the way this works right here with wrap with div tags, is now I give it this parameter. And again, I mentioned this before, but you could think of this code right here. If I were to comment that out, you could think of that as being like this. So now this function is just sitting there waiting for this one last parameter, which is this HTML stuff that I might type in. Really, I'm just typing in strings, but if I was typing in full HTML, that's what that would be right there. So conceptually, that's what the function looks like right now. But in the real world, this is what we use right there. So that's a second example, and I think it's a little bit more real world than the first example I showed. I already have this set up, so for our third example, imagine that you want to write a logging application or a logger. And so I have these log levels already defined, and then I import those right there. And now what I'd like to do is create a logger or a logging function like that. So this is a function that expects a log level as its first parameter. So it could be any of these right here, and then a logging message, whatever it is that you want to write out. And then I call println here. And of course, you could have other ways of logging at this point, but I'm just using println right now. So let's get rid of that. And what happens here, this is actually very similar to the previous situation, is you might say, well, I want to log at the info level. And again, not having anything clever to say, I'll just say, hi, mom. And then I might do another log, and that would be, hi, dad. And then another one would be, hi, Rover. And now you see that this is actually the same as the previous situation. This is becoming repetitive because I keep logging at the info level. And you would say, well, wouldn't it be nice if I could just have like a log info function? And then I could do that. And then I could have another log info right there. And then I know that this function goes directly to the info level. And again, that's what partially applied functions do for us. And I do that the same as I did before. So I say log info equals that log function, and I give it the info parameter it wants as the first one. And now I don't give it anything for that string parameter right here. So again, log info is a partially applied function. And as I hover over this, you can see now log info is waiting for you to give it a string, and it will transform that into a unit. And that's because it's going to take this string right here and print it out with println, and println just returns units. So that's why this function right here, and I need to be clear that log info is a function right now. And if you followed along from previous lessons, especially when I was talking about higher order functions, this is the type signature that you would see for higher order functions. So this is a function, which you can tell by that transformer symbol right there. This is a function that transforms a string into a unit. That's the way you read that. So now log info should be primed and ready to go. This code should work. And these two lines in particular right here should print to the info level, just like that one does right there. So let's save that. And we see the output right there, just like that. All three of them are at the info level. So again, these are called partially applied functions, and that's because we've only partially applied the parameters given to it. And the common pattern that I mentioned here at the beginning might make more sense now. So you pass the common variables you want into a given function, so a function that already exists, like log. Let me scoot that over here a little bit. So you pass common variables into a function that already exists. So log already exists. I pass the common parameter in there, and then I leave that parameter off. And that creates a new function with those preloaded values. So in this example, that creates this new function that has info preloaded. And then you use that new function and passing it only the unique variables it needs. And that's what I do down in this area here. So we did that over here, and then I used the same pattern over here where I started off with a general function. I created a more specific function, and then when I went to use that specific function, I passed in only the parameters it needed. And I did the same thing over here. I started off with the general sum function. I created a more specific function by skipping those two parameters, and then I used that specific function, giving it the last two parameters it wanted. And then I did the same thing here, creating a more specific function by giving it two parameters here, not giving it the third parameter, and then you had to add the third parameter in later. So that's how partially applied functions work. And if you want more details, I have this article here, and I believe this is more of an introductory article. And then I have this one over here, and this one comes from my book, Functional Programming Simplified. And if you look at the length of the nugget over here on the right, you can see this is a relatively short article, and this nugget is much smaller, and that gives you an idea that this is a much longer article over here. So if you want more details, check out this article first, and then check out this much longer article here.